In this video, I'm gonna go over angular displacement, displacements, and distance in circular motion. By definition, angular displacement is the angle through which an object moves in its circular motion. Let's consider an object at the point A, and then it moves on the circumference of the circle for a few degrees or a few radians. Actually, I have an initial radius like Ri pointing to A, and the final radius like Rf, a place vector pointing to B. Here, the openness between these two radii is called angular displacement. Do not make mistake about displacement and distance. These two quantities have always different magnitudes in circular motion. Here again I start from A, I will go to the B on the circle. And then here I have angular displacement. But what do I mean by distance traveled? Distance traveled by definition is the arc length, the length of the trajectory from A to B. So this is the distance. According to definition of theta in radian, we will have a ratio. The ratio is the distance traveled divided by radius. Distance actually is the arc length, this definition of the radian. So I can use this formula to find the distance traveled, r, radius of the circle, times theta. But theta must be in radian. Be very careful. The other is the displacement. Actually, the displacement is a vector connecting A to B. That's all. This is a vector. How to find that? It's very easy. Here I have an isosceles triangle. The legs of this triangle are radii of the circle, and this is the subtraction of them. Actually, let's say this is delta r, or displacement. How to find that? It's very easy. If the openness is theta here, delta r, according to vector analysis, is going to be 2r sine of theta over 2. So easily I can find the displacement by 2r sine of theta over 2. Displacement is found as the base of the isosceles triangle with legs of r. A car in a roundabout of radius 100 meter has an angular displacement of 60 degrees. Okay, we have a circle radius of 100 meters, and this angular displacement seems to be 60 degrees, or pi over 3, the radian. Find the displacement at the distance traveled. Distance is very easy, Distance is the arc length here, so distance is going to be r theta, and we know that we should use theta in radian. So let's use 60 degrees as pi over 3. And r also is 100 meters, so it's 100 pi over 3. I don't want to plug in the pi. Let's leave it like that. Anyway, 100 is measured in meters, so distance also is measured in meters. What about the displacement? Displacement is a vector connecting the beginning point and ending point. This is the base of this isosceles triangle. So let's say the displacement is d here. Or if you want, you can write delta r. Is going to be 2r sine of theta over 2. So it's 2 times r. R is 100 sine of 30 degrees. That's all. In sine function, you can use radian or degrees. It's okay. So the answer is going to be 2 times 100 times 1 over 2, because sine of 30 degrees is a half, so it's 100 meters. That's all. This is the displacement of this motion. Thank you for watching this video. This was an introduction, and in upcoming videos I will delve into circular motion and I will introduce different quantities. See you.